Good morning. You can unmute yourselves and reply. I said good morning. I just want to know whether I'm audible or not. Okay. I'm Anil, Assistant Professor in the Department of Mathematics, and I'm responsible for handling your mathematics classes this semester. Be regular to the classes. Do not miss even a single class, and prepare your own notes every day. You make a practice of this. And do not forget to keep a pen and a notepad with you while attending the classes. Title of the subject is Advanced Calculus and Numerical Methods. This is the subject I'm going to handle for your class. Advanced Calculus and Numerical Methods. Course code is 18MAT21. This is the course code. You remember this, 18MAT21. There will be 40 marks for internals and 60 marks for external examination. External examination will be conducted for 100 marks and then it will be reduced to 60. This subject, advanced calculus and numerical methods, are very important and they are the fundamental to all higher mathematics and its applications. These topics form the core of the basic requirements in mathematics for students in science and engineering, without which we cannot do anything. And we have 5 modules included in the syllabus. In the first module, we study vector calculus. In the first module, we study vector calculus, and this vector calculus comprises of vector differentiation in the first part, vector differentiation, and in the second part, vector integration. This is vector calculus. Here we study gradient, directional derivative, curl, divergence, solenoidal and irrotational vector fields in the first part. And in the second part, we study line integrals, theorems of Green, Gauss, and Stokes theorem, application to work done by force and flux. Comparatively, this is a little difficult topic. Therefore, I prefer to do this in offline mode. So I start with the second module. We'll do it later, first module, because comparatively this is a difficult module. I start with this module, module 2, second module. I go with this order. First I do second module, and then third, and then fifth, and then first, and then fourth module. We'll go in this order. First, second module, and then third module, and fifth module, and then first module, and fourth module. In the second module, we study second and higher order linear differential equations, ordinary differential equations with constant coefficients. Variation of parameter, this is another method. Variation of parameter, and Cauchy's and Legendre's differential equations. They are also linear differential equations and applications. This is a simple chapter. Next, third module. Third module is partial differential equations. Here we study formation of partial differential equation. Formation of partial differential equation by eliminating arbitrary constants, by eliminating arbitrary functions, and solution of homogeneous partial differential equation by direct integration. Homogeneous partial differential equations involving derivatives with respect to one independent variable only. And then solution of Lagrange's linear differential equation. Derivation of one-dimensional heat and wave equations and their solutions by the method of separation of variables. This is third module. Next, fourth module. This is another difficult chapter, another difficult module, I say. Here we study infinite series in first part. Series of positive terms and their convergence and divergence by Cauchy's root test and D'Alembert's ratio test. This is first part of this module. And in the second part, we study power series solution of differential equations. Series solution of Bessel's differential equation leading to Bessel's functions. Series solution of Legender's differential equation leading to Legender's polynomials and Roderick's formula. This is fourth module. And last one is fifth module. This is a numerical method. Numerical methods. Finite differences, interpolation and extrapolation using Newton's forward and backward difference formula, Newton's divided difference and Lagrange's formula, all are without proof, solution of polynomials and transcendental equations by Newton-Raphson and regular-Falsy methods. And in the second part, we study numerical integration by Simpson's 1/3 rules, Simpson's 3/8 rule, and Wedel's rule. This is about the syllabus. Next, we shall start with the second module, prerequisites. I expect knowledge of differentiation, integration, and the basics of arithmetics as prerequisite to study second module. You are familiar with the differentiation and integration. This is a prerequisite to study the second module. Find the roots of m cube minus 3m plus 2 is equal to 0. This is a very simple equation, cubic equation. M cube minus 3m plus 2 is equal to 0. How do you approach this? How do you find roots of this cubic equation? First, by inspection, find a root. Put m is equal to 1. If you get 0 is equal to 0, then conclude that m is equal to 1 is a root. Otherwise, check m is equal to minus 1. If you get 0 is equal to 0, then conclude that m is equal to minus 1 is a root. Next, check m is equal to 2. If you get 0 is equal to 0, conclude that m is equal to 2 is a root. Otherwise, m is equal to minus 2. M is equal to plus 3. M is equal to minus 3. Within that, you get a root. First, let's check this. Put m is equal to 1. When m is equal to 1, this equation will be 1 cube. 1 cube is 1. Minus 3 into 1 is 3. Plus 2 is equal to 0. 1 minus 3 plus 2 is 0. 0 is equal to 0. Therefore, by inspection, m is equal to 1 is a root. By inspection, m is equal to 1 is a root. Now let's go for synthetic division method. First, you write the coefficient of this m cube, cubic term. It is 1. Next, you write coefficient of m square. There is no m square here. Therefore, its coefficient is 0. Next, coefficient of m, that is minus 3. Next, constant, that is 2. Here, in the first position, always write 0. In the first position, always 0. Add these two. 1 plus 0 is 1. Multiply these two. 1 into 1 is 1. Add these two. 0 plus 1 is 1. Multiply these two. 1 into 1 is 1. Add these two terms. Minus 3 plus 1 is minus 2. Now multiply with this one. Minus 2 into 1 is minus 2. 2 minus 2 is 0. You must get 0 in this position. Then only you can conclude that what you have done is correct. Now this cubic equation is reduced to a quadratic equation, that is 1 into m square, m square. 1 into m square is m square. 1 into m is m minus 2 equal to 0. This cubic equation is reduced to a quadratic equation. Rest is very simple. You can easily factorize this. How do you factorize this? M square plus this m can be written as 2m minus m minus 2 equal to 0. M square plus 2m minus m minus 2 is equal to 0. You take m as common factor. As m comes outside, what you get within the brackets is m plus 2. And here, take minus 1 as common factor. As minus 1 comes outside, you get m plus 2 inside the brackets. This is equal to 0. Therefore, m minus 1 into m plus 2 is equal to 0. Product of these two terms is equal to 0 implies at least one of the two terms is equal to 0. That is either m minus 1 is equal to 0 or m plus 2 is equal to 0 or both equal to 0. If m minus 1 is equal to 0, then m is equal to 1. If m plus 2 is equal to 0, then m is equal to minus 2. So collectively we have three roots here. M is equal to 1. And then m is equal to 1. And then m is equal to minus 2. All the three roots are real. Two roots are coincident and one root is a distinct root. Is this clear? This division, synthetic division. You can unmute yourselves and reply. At least type in chat box. How to consider the value of m. You start with plus 1. This is a trial and error method. That's why we call it as inspection method. First you put m is equal to 1. If you get 0 is equal to 0, then m is equal to 1 is a root. Otherwise, check m is equal to minus 1. If you get 0 is equal to 0, it's a root. Otherwise, m is equal to 2, m is equal to minus 2, m is equal to plus 3, m is equal to minus 3. Okay, repeat. Here, this is a cubic equation. There will be three roots for this equation. First, by inspection, we have to find one root by inspection method. Inspection method is first you check m is equal to 1. If you get 0 is equal to 0, then m is equal to 1 is a root. If you do not get m is equal to 1, m 0 is equal to 0, then check m is equal to minus 1. If you get 0 is equal to 0, then conclude that m is equal to minus 1 is a root. Next, you check m is equal to 2 and m is equal to minus 2. If you get 0 is equal to 0, 2 is a root. Otherwise, check m is equal to minus 2. M is equal to plus 3. M is equal to minus 3. Within this, you get a root. Here, let's check. First, m is equal to 1. When m is equal to 1, m cube will be 1. Minus 3 into 1 is 3 plus 2 equal to 0. Therefore, 1 minus 3 minus 2 plus 2 is 0. 0 is equal to 0. Therefore, m is equal to 1 is a root. You need not verify these because we get m is equal to 1 as a root here. Therefore, you need not verify these. M is equal to minus 1, m is equal to 2, minus 2, 3, minus 3. So, m is equal to 1 is a root. Then go for synthetic division. M is equal to 1. This is the root. Now, synthetic division goes like this. First, m cube coefficient, that is 1. Next, m square coefficient is 0. Next, m coefficient is minus 3. Next, constant. M cube coefficient is 1. There is no m square here. Therefore, its coefficient is taken as 0. M coefficient is minus 3 and constant is 2. And here in the first position, always write 0. Add these terms. 1 plus 0 is 1. Multiply these two terms. 1 into 1 is 1. 0 plus 1 is 1. 1 into 1 is 1. Minus 3 plus 1 is minus 2. Minus 2 into 1 is minus 2. Add these two terms. 1 plus 0 is 1. 1 into 1 is 1. So write it here. 0 plus 1 is 1. Multiply with this. 1 into 1 is 1. Write it here. 1. Minus 3 plus 1 is minus 2. Multiply with this. M is equal to 1. Minus 2 into 1 is minus 2. Write it here. Plus 2 minus 2 is 0. We must get 0. Then only we can conclude that what we have done is correct. Now this cubic equation is reduced to a quadratic equation. This is m square coefficient, this is m coefficient, and this is constant. Therefore, m square plus m minus 2 equal to 0. You know how to factorize this. Next, you take one more such problem. M cube plus 1. No symplectic division is required for this. M cube plus 1. Okay. M cube plus 1. How do you write this? M cube plus 1. How do you approach this? M cube plus 1 is equal to 0. A cube plus B cube. A cube plus B cube is A plus B into A square minus AB plus B square. Right? A cube plus B cube is A plus B into A square minus AB plus B square. M cube plus 1. 1 can also be written as 1 cube. So writing m cube plus 1 is equal to 0 is same as writing m cube plus 1 cube is equal to 0. Clearly, it takes a cube plus b cube form. It can be written as a plus b. That is m plus 1 into a square, m square, minus ab, minus m into 1 is m plus b square. B square is 1. This is equal to 0. Clearly, the product of these two terms is equal to 0. This implies at least one of the two terms is equal to 0. That is either m plus 1 is equal to 0 or m square minus m plus 1 is equal to 0. If m plus 1 is equal to 0, then m is equal to minus 1. Or m square minus m plus 1 equal to 0. This is a quadratic equation. Now let's solve this quadratic equation. We know that m is given by, what is the expression to solve quadratic equation? Minus b plus r minus square root of b square minus 4ac divided by 2a. What is a, what is b, what is c here? A is m square coefficient, therefore a is equal to 1. B is m coefficient, therefore b is equal to minus 1. And c is constant, c is equal to 1. Therefore, this is equal to minus b. B is minus 1, therefore minus b is plus 1. Plus r minus square root of b square minus 1 whole square. Minus 4ac, 4 into ac. A is 1, c is 1. Therefore, ac is 1. Divided by 2a. A is 1, therefore 2a is 2. Therefore, this is equal to 1 plus r minus square root of minus 3 divided by 2. Or this can be written as 1 plus r minus, how to write square root of minus 3? Square root of minus 1 is imaginary, it is denoted by I, right? Square root of minus 1 is always I into root 3 as it is divided by 2. This is what we require. Collectively, we have 3 roots now. M is equal to minus 1 is 1 root here. And m is equal to 1 plus r minus I into root 3 divided by 2. Here we have two roots, 1 plus I into root 3 by 2 and 1 minus I into root 3 by 2. So there are three roots. One more. This is a biquadratic equation. 4m power 4 minus 4m cube minus 23m square plus 12m plus 36 equal to 0. This is a biquadratic equation. How do you approach this? As it is, you cannot simplify or factorize this. So by inspection method, you have to find one root. By inspection method. First check m is equal to 1. Check m is equal to 1. If we get 0 is equal to 0, then conclude that m is equal to 1 is a root. What happens here? M is equal to 1. 1 power 4 is 1. 1 into 4 is 4. Minus 1 cube is 1. 1 into minus 4 is minus 4. Minus 23 plus 12 minus 36 equal to 0. Is this true? This plus 4 will get cancelled, this minus 4. Minus 23 plus 12 minus 36. Is this equal to 0? Clearly it is not equal to 0, right? This is not true. Minus 23 plus 12 minus 36 is not equal to 0. Therefore, m is equal to 1 is not a root. Next check m is equal to minus 1. When m is equal to minus 1 power 4 is 1. 1 into 4 is 4. Minus 1 power 3 is minus 1. Minus 1 into minus 4 is plus 4. Minus 1 whole square is 1. 1 into minus 23 is minus 23. Minus 1 into 12 is minus 12 plus 36 equal to 0. Is this true? 4 plus 4, 8. 8 minus 23 minus 12 plus 36 equal to 0. It is not true. This is not equal to 0. This is not true. This is not true. This is not true. Therefore, we have to verify m is equal to plus 2. M is equal to plus 2. Check it. When m is equal to plus 2, what you get here is 2 power 4. 2 into 2 into 2 into 2. That is 16, right? 16 into 4, 64. When m is equal to 2, 2 power 4 is 16. 16 into 4 is 64 minus 2 cube is 8. 8 into minus 4 is minus 32. 2 square is 4. 4 into minus 23. 12 into minus 2, minus 24, plus 36 equal to 0. Is this true? 64 minus 32 minus 23 into 4, that is 92, minus 24 plus 36. Clearly this is 0. We get 0 is equal to 0. Now we can conclude that m is equal to 2 is a root. M is equal to 2 is a root. This is by inspection. M is equal to 2 is a root. Now we go for synthetic division. M is equal to 2. M is equal to 2. We go for synthetic division. First we write m power 4 coefficient. Coefficient of m power 4 is 4. Next m cube coefficient, that is minus 4. Next m square coefficient, minus 23. Next m coefficient, 12. And last 36. And here in the first position, always write 0. Add these two. 4 plus 0 is 4. Multiply these two. 4 into 2 is 8. Write it here, 8. Now add these two. Minus 4 plus 8 is 4. Multiply these two. 4 into 2 is 8. Minus 23 plus 8 is minus 15. Multiply these two. Minus 15 into 2 is minus 30. 12 minus 30 is minus 18. Now multiply these two. Minus 18 into 2 is minus 36. We must get 0 here. Therefore, the biquadratic equation, this is biquadratic equation, is reduced to a cubic equation, that is 4m cube. This is m cube coefficient now. M cube plus 4m square minus 15m minus 18 is equal to 0. Now by inspection find one root for this equation. There will be 4 roots for a biquadratic equation. This is a biquadratic equation. Therefore, we have to find 4 roots here. Among the 4 roots, m is equal to 2 is a root. So by inspection, you find one more root. One root for this equation now. 4m cube plus 4m square minus 15m minus 18 is equal to 0. Verify. M is equal to 1 and m is equal to minus 1 are not roots of this equation. Therefore, you need not check it here. M is equal to 1 will not satisfy this equation. M is equal to minus 1 will not satisfy this equation. Therefore, start with m is equal to 2 only. M is equal to 2. 4. Again 4 minus 15. First verify whether m is equal to 2 is a root of this or not. You do that part. Put m is equal to 2 and let me know whether it satisfies this equation or not. Yes, m is equal to 2 is a root. Okay. Therefore, by inspection, m is equal to 2 is a root of this equation. Now reduce this. 4 and then again 4 minus 15 minus 18. Here in the first position, always 0. 4 plus 0 is 4. 4 into 2 is 8. 4 plus 8 is 12. 12 into 2 is 24. Minus 15 plus 24 is 9. 9 into 2 is 18. Minus 18 plus 18 is 0. Therefore, this cubic equation is reduced to a quadratic equation. 4m square plus 12m plus 9 equal to 0. Best you can do. How do you factorize this? 4m square plus 12m is 6m plus 6m plus 9 equal to 0. Here from first and second terms, you take 2m as common factor. Then what you get within the brackets is 2m plus 3. Plus from third and fourth terms, you again take 2m as common factor. And not 2m, just 2. Just 3. We get 2m plus 3 equal to 0. Therefore, 2m plus 3 into 2m plus 3 is equal to 0. 2m plus 3 is equal to 0 implies m is equal to minus 3 by 2. Here also m is equal to minus 3 by 2. Now we have 4 roots. M is equal to 2, m is equal to 2. These two are real and repeated. M is equal to minus 3 by 2, m is equal to minus 3 by 2. These are also real roots and repeated roots. This is a biquadratic equation. Similarly, I give one more problem. See, this similar problem. You try this one. And put your attendance in the chat box. your USN along with your name. You type here in the chat box. Both USN and name. Samarth G, type your name also. Mrs. Rukmini, type your name also. Name along with USN required. You try this problem. First, by inspection, try to find a root. Put m is equal to 1 first. When m is equal to 1, this will be 1 power 4, that is 1, minus 2 into 1 cube is minus 2, plus 2 into 1 square is 2, minus 2 into 1 is minus 2, plus 1, this is equal to 0. Clearly, this LHS is 0, therefore we get 0 is equal to 0. Therefore, we conclude that m is equal to 1 is a root. M is equal to 1 is a root. Now, by synthetic division method, we shall reduce this by quadratic equation into a cubic equation. Coefficient of m power 4 is 1 and that of m cube is minus 2. M square is 2. M is minus 2 and constant 1. And here in the first position, always 0. Add these two. 1 plus 0 is 1. 1 into 1 is 1. Minus 2 plus 1 is minus 1. Minus 1 into 1 is minus 1. And 2 minus 1 is 1. 1 into 1 is 1. Minus 2 plus 1 is minus 1. Minus 1 into 1 is minus 1. 1 minus 1 is 0. Therefore, this biquadratic equation is reduced to a cubic equation. Now, this is coefficient of m cube. M cube minus m square plus m minus 1 equal to 0. M cube minus 1 into m square minus m square plus m minus 1 equal to 0. One root is obtained. Now the biquadratic equation is reduced into a cubic equation. As it is, you can factorize this. It's a very simple equation. You can easily factorize this, or you can find another root by inspection method and go for synthetic division method. Here m cube minus m square, you can take m square as common factor, then what you get within the brackets is m minus 1 plus here 1 into m minus 1 equal to 0. Therefore, m minus 1 into m square plus 1 is equal to 0. Therefore, either m minus 1 is equal to 0 or m square plus 1 is equal to 0. M minus 1 is equal to 0 implies m is equal to 1. M square plus 1 is equal to 0 implies m square is equal to minus 1. Therefore, m is equal to square root of minus 1. And square root of minus 1 is denoted by plus or minus 1. Therefore, the four roots are m is equal to here 1, here again 1, and plus or minus I. Two roots are real and repeated, and two roots are complex roots. One more problem is that you try this one by yourselves at your home. We have less than 1 minute left, therefore I cannot solve this. You try this one by yourselves at your home. If you find difficulty, you can ask me in the next class. Thank you.